So still on equipment reliability, like we said earlier, we will now look a little bit in details. Okay, the bathtub failure curve. Okay, so like we said, if you look to the left of the curve, that is caused by, if you see that the graph is failure rates times time, or unreliability as against time. Okay, now if you look at it, you see that when the equipment is newly installed, the probability of failure is high. We want to ask, the equipment is newly maintained, it is new, how then the probability of failure will be high? There are several reasons why the probability of failure could be high. Remember, if it is a mechanical component, remember, especially rotating mechanical component, remember these components, they are new. Okay, they've actually not operated, and you'll see that they need some time to actually bed in. Okay, so that time between the startup and when they actually bed in, you see that the probability of failure is usually very high, because there will be high rate of wear, okay, and even tear in that infant stage. That is one. Then secondly, the manner of handling of this equipment from the manufacturer to your facility. Okay, the condition under which it was transported and the condition under which it was handled in your store, those can induce conditions that can cause failure to the equipment. Then the installation process also, if it is not reliable, they can induce failure at that infant stage of the assets. Okay, so these are some of the conditions. Then if it is an asset that is already in operations, things like intrusive maintenance program that you do, can also have maintenance induced failure that can cause this infant mortality, increase in the infant mortality rate, okay, on our assets. Then if the assets survive this period, it has now bedded in, will now enter the normal service life. Okay, these are the useful service life. So any failure that will occur on this part of the curve, they are random. Like we discussed earlier, if you remember what made the component phase, okay, stressors can be introduced into the process at any time that can cause or initiate the failure of these components in the system. Okay, so these random failures, they are random because we do not expect them. Like we said, most of our maintenance program, they are designed they are designed with the notion that with the mind that the equipment will always run through its useful life and come to the wear out period or the old age. Okay, so before it gets to the wear out, let us do some maintenance. We'll see that later. Are we getting it? So that will make us not to catch the components or the asset when it is failing around this useful life, and that is one of the reasons why we have unplanned that we have breakdown that result to unplanned maintenance most of the times on these assets. Okay, so an integrated reliability program will help us to see when, even in this phase of the equipment life, when the equipment is about to fail, there are technologies that will help us to actually look at it. Then when the equipment has come to the end of its life, useful life, you see that the probability of failure will start increasing again. Okay, so here is the potential point of failure. Okay, and then here is that is where it starts showing signs that it wants to fail, and here is where it eventually fails, which is old age. Okay, so that is the wear out period of the facility of the assets. Are we getting it? So this bathtub curve is what guides most of our operations. But remember, that particular asset is made up of different components. Different components. If you take your diesel engine as an example now, you discover that the diesel engine have different components. We have the crankshaft, we have the connecting rod. Between the connecting rod and the crankshaft, we have the metals or metal bearings. Okay. Then we have the piston rings, we have the gasket on the top cylinder, we have the top cylinder, we have the valves, and we have other components. And you see that these various components, they are subjected to different stress levels as the diesel engine is operating or as the reciprocating engine is operating. So you will see that they all tend to fail at different times, and that is what you see on the graph below. Okay, and all of this, they are what contributes to the random failure that we are discussing before. Are you getting it? So these components, they have different life. So you are assuming this is that of the bearing. Okay, this could be that of the gasket. Are you getting it? This could be that of the piston or rings. So they fail at different times, and manufacturers, they know this. So we'll see the usefulness of knowing this or incorporating this into your reliability program as that is later. Okay, so now this bathtub curve is what we have here now. Remember, this is the infant stage through the normal operations, then through the wear out stage. Like we said, we want to catch these components or equipment when they are entering this wear out stage. So you see, manufacturers, okay, usually when you buy equipment from them, they design a maintenance, that is, it comes with a maintenance program, like a suggestion to you, the kind of maintenance that you carry out, the time interval when you start using the equipment, the amount of time it will take for you to do some change outs on those equipment, the amount of time it will take for you to do oil change outs, bearing change outs, and do some checks, also maintenance checks. Okay, so from the experiments that they've carried out and also feedbacks from users like us, they've come to realize that if you use this equipment for so much time, this component is bound to be tending towards the wear out period. Okay, let's take the bearing for example now, or the carbon brush for example now on your DC motor or generators. Okay, so they will feel that when you use this equipment for so much time, that component would have been going into the wear out stage. So before it enters the wear out stage, do what? Change it out. Okay, so the idea is to bring this curve down back. So you see that when the equipment operates to this level, you change out. Okay, you are not giving that component the chance to go into the wear out region. Okay, you now succeed in bringing down the curve again. Until it gets to this level, you change out. Okay, so that is what actually informs most of the PM programs that we have in our facility. When you use the equipment or the asset for 2 months, change the oil. Use the equipment or the asset for 3 months, change the bearing. Are we getting it? So that is what actually, this is what actually inform those PM intervals. Okay, so, and that is what we are seeing here. This determines our PM intervals. Okay, the regular interval, because of the assumption that that component will be going into this stage. But experience have shown that when you go out to do some change out, okay, you see clearly that that component that you are changing out still have some useful life in them. What do you have to do? You still have to change out, because PM said you should change out. But look at the curve again. You see that as you are doing that change out, you are introducing that infant mortality region again into the life of your equipment. And I know you may have experienced it too. Equipment after maintenance, during commissioning, or during recommissioning, or a short while after recommissioning, the equipment fails again. That same component fails again. It is because of those maintenance-induced error, or the component entering this region, this infant mortality region of the equipment. Okay, so maintenance-induced error, the handling error, as we said, of components. Okay, the component that, the integrity of the component that you are even bringing from store, from your supplier, all of this can make us to experience all of these high probability of failure, less reliability. So you see that the PM program, or most of the maintenance program that we have in our facility, does not actually take care of our reliability issues. Okay, but as you can see, this random failure that is caused by these various components, we actually could not determine them. So the unplanned downtime, or the unplanned failure, let me put it like that, unplanned downtime, okay, random failure, will always occur with this kind of so now, remember we said the infant mortality region, most of the unreliability issue, or the reliability issues that we have, they are actually induced. Okay, either maintenance induced or because of the equipment. So how do we take care of any failure that will happen around this infant stage? The first, we have to have a better quality control, ranging from the procurement process through the installation process. Are we getting it? We have to have a better quality control. So if we are getting that component from the manufacturer directly, or is known agents or rep around us, okay, recommended by them, okay, so we want to make sure that we get those quality materials. Okay, then those that will be doing the installation, we have to be sure that they know precisely what they do and the effect of each and every action they take on the asset itself. So we want to design a standard SOP, standard on the installation process, okay, or the maintenance process. We want to design a standard SOP. Remember, we want to also make it a reliability, a culture in our facility, so that each and every personnel involved with that asset knows how his actions will affect the reliability of the asset and eventually affects the bottom line of the company, and thus what is expected of him to take home. So our personnel need to be knowledgeable, trained, and there should be an SOP that also determines the quality of the job that will be executed at the end of the day. So we want to ensure the reliability of the personnel, the people, okay, through training, ensuring that they have the required skill to carry out the necessary maintenance the necessary maintenance and installations that needed to be done. Then we need to also ensure precision assembly. Okay, so this will be determined if we have a standard operating procedures, okay, for the assembly. Then precision installation too, okay, the installation process need to be clearly defined, not something that will be subject to the knowledge of the individual doing the installation. Are we getting it? So we need to ensure precision installation with precise SOP, defining all the tolerance limits, okay, in the process. Then we need to ensure, as we said earlier, that we do not use substandard materials. Okay, if we use substandard materials, that will compromise the integrity of our system or of our assets. Okay, then we also want to ensure that there are no manufacturer's errors. Okay, that we can do by factory acceptance testing, and if possible, testing at the delivery point. Okay, but factory acceptance testing will help you to see if there are errors at the manufacturing level. Okay, then the packaging too also helps us to take care of the error that may be introduced during the handling as we are transporting the asset or the equipment to our facility. Okay, so next, how do we take care of problems that could, or unreliability that could be induced during the random life or the normal operating life, okay, of our asset? That is the random stage, that is this stage now of our system. Remember, most of the failure that we experience here could be as a result of maloperations, and those maloperations, like we said, will result to some stress level that is beyond what the components of the asset is designed for. Or it could be as a result of environmental conditions. All of them, if you look at it, you see that they are all stress induced during the normal operating life of the assets. Okay, so how do we take care of those? One, we want to have a proper ROCM program in place. Okay, so the ROCM program will help us to optimize maintenance strategies, the maintenance strategies that we deploy. So you see that since we have different maintenance, that is, we have maintenance mix in ensuring the reliability of our system, we want to harness the best, let me say, or the useful parts of each of these maintenance strategy in our facilities. Okay, what this means is that those components that it is more feasible for us to run to failure, we'll run them to failure. More feasible and more economical, okay, we'll run them to failure. Those that it is less feasible, not economical, we want to see how we can do preventive maintenance program on them, that is time-based maintenance program like this. Okay, then those components that we feel can be replaced when they have useful life in them, or they can fail before the PM program, we can deploy condition monitoring on them. So we want to have the right mix of these various maintenance strategies. Okay, and that is exactly what the reliability centered maintenance program, okay, will do for us, or ROCM. Like we said earlier, we want to deploy condition monitoring so that each of these components, before they enter the wear out stage during the normal operating life of the equipment, we will see them. Okay, so if there is a stress level that drives the integrity of that component down, okay, or drive that component into the wear out region of the curve, okay, with condition monitoring, we'll be seeing it. We'll see it and then initiate a maintenance process to take care of that failing component. Okay, then like we said before, the operators too, if the equipment is not properly operated, they can induce a failure. Okay, subject the components of the equipment or assets to a higher level of stress that will eventually cause the failure of the equipment. Total productive maintenance, where the assets is taken care of by everyone, so to say. Maintenance operations, what you need to do, okay, knowing clearly how your actions will affect the reliability of the assets, okay, and thus the production of that particular asset and eventually the revenue that will come out from that your production process. Okay, so all that everyone need to do, precision maintenance like laser alignment and what have you, to ensure that those tolerance level that has been defined, be it vibration, be it alignment, be it clearances, any tolerance level that has been defined, we want to precisely meet those tolerance levels in all of your facilities to ensure the reliability of your facility. Of course, material choices, as we saw earlier in the infant mortality stage, okay, we want to ensure that the materials that we use at this stage, they are all reliable materials that will improve the reliability of our assets. Okay, and of course, we want to have instrumentations in place that will help to protect the equipment against some failure mode or some stressors. Okay, if you look at maybe electrical system, for example, now we have lightning protection that helps to protect the equipment against voltage spikes that is far beyond its normal operating voltage level. Okay, then if it is mechanical equipment that we are looking at, maybe we are looking at the components, tubings or pipings, the pressure relief valve that will help to relieve the pressure in a particular vessel or in a particular tubing. You understand? Those are protective devices that will help to protect against those stressors that compromise the reliability of our system. So those age-related failure, or when the equipment is the wear out region, okay, what are some of the things that we can do also to ensure the reliability of the asset? One, once we know that once equipment goes to the wear out period, the rate of failure will increase, okay, which means that we want to carry more inventory, maintenance parts. Are we getting it? That is if you allow it to get to that area. Remember, one of the KPIs, okay, that we look at is the cost of maintenance to the equipment replacement value. Remember, we said if it is more than 1.2% or 1.5%, okay, then we should be looking at replacing that equipment. So as the cost of maintenance, as the equipment is getting older, entering that wear out period, wear out region, you see that the cost of maintenance will be going up. Okay. So as you have seen, for us to continue using we will need more parts. Okay. Then of course we need stronger materials. So we want to go for components that will be able to withstand more stress than the one that we use, that we are used to, or that the one that we've been using on the assets. Okay, so which means we need a higher rating of components so as to be able to help us to withstand that increased failure probability in the equipment. Then of course we want to be considerate when operating the equipment in this region. This is the region where we recommend derating the equipment, subjecting it to lesser stress than it is designed for. Okay, so that is one way we can do it. Okay, so we also want to manage the degradation. Okay, and one of the things that we can do is to increase the rate of our condition monitoring on the asset or the component of the asset. Okay, as we increase the rate, the frequency of condition monitoring, that will help us to see when the equipment or the component is actually entering that wear out region, since that time interval has been shrinked because of the age of the equipment. We can also increase our PM interval if that is what is feasible. Okay, that is if our PM says 2 months before, we can reduce it to 1 month. Are we getting it? Thereby increasing the interval from 1 to 2 within that 2 months. Okay, we do not want to joke with maintenance. All our maintenance programs should be done timely. If it is not done timely, then it means that the chance of the asset or the component of the asset driving into that wear out period and eventual failing before our knowing will also increase. So all of this will put together, they actually has to do with the age exploration. Okay, that is, we want to deploy maintenance program with the condition of the asset in mind, that we are already entering the wear out period of that particular asset. Okay, increasing the frequency of preventive maintenance program, condition monitoring, and what have you. Okay, to manage the assets in that area, derating the assets, okay, make it to produce lesser than what it is designed for, subjecting it to lesser stress and what have you. So all of those are the things that we do during the age exploration of that asset.